moving.
So how long such an event lasts? Is it like 1 hour or 1 day or a couple of minutes?
I'm not exactly sure because I don't work in this field, but I think it lasts of the order of minutes, if not tens of minutes. It's not unusual. It happens quite often. Of course, they are looking for big flares. And they have seen many now, so they don't really care about small flares. They would like it to see a big flare to measure really how it increases and how it drops. And a lot of them are not caught by any eyes because you need very high angular resolution instruments in the infrared looking really in this particular zone with a high angular resolution at a precise time. And you cannot forecast it, let's say. You just have to be lucky. Well, it's not lucky because you just know that it happens quite often. And these people get quite a lot of observing time. So in the end, they get a few flares. They can characterize them. But I remember seeing one, and for me, it was the first time. So I was quite new, so I was impressed.
I think we all would be.
Yeah, we are, just by talking to you.
So at the observatory, what's great basically is to change also. It's the variety of things that we do, because since we do service mode observing, we observe for other people, mainly in Europe, but not only. It's great because sometimes you look at the galactic center, it's a very crowded field with very beautiful stellar patterns and rings and things like that. It's very, very crowded and very red. You can only see in the infrared there. And then you switch instrument or you switch program, and then you observe a very bright star where there is hope for an exoplanet. And then you switch to a quasar, and then you switch to an asteroid, and then you switch to a trans-Neptunian object, and then you switch to... really, we do different things sometimes in one single night, and that's really, really nice.
Wow, so you look at everything from the edge of our solar system right the way up to the edge of our galaxy.
Exactly. It's not the case of all instruments, but the three instruments that I do operate on the telescope, usually working at night. So it's an 8.2 meter telescope with three huge instruments. Each instrument weighs about 2 tons, and they are huge facilities, really. And these instruments, which are all three in the infrared part of the spectrum, they are able to do very different things. And so it can be very high redshift galaxies, like a tiny, tiny faint spot that we found spectroscopically. We can explain that it's a very far galaxy, very far, far away, actually closer to the Big Bang. And it's also the same instruments that are able to look at the galactic center and exoplanets. And something that I've also found striking was a lensed quasar. So you see a quasar which is so far away that there is some kind of matter in between the quasar and us, and the quasar light is deflected also by the Einstein's theory, by the mass that's in between. So you have like a lens effect, and instead of seeing one spot, you see four, like a cross. And I observed one that was really, really nicely resolved, and you could really see like a perfect cross, 4 different spots. Found that quite amazing, and that was also possible thanks to adaptive optics.
That you can do with how many meters telescope?
With an 8.2 meter telescope.
8.2 meter telescope. When you think how Galileo started with a 1 inch and in 400
the advantage of Galileo, it was not disturbed by the atmosphere.
No, he wasn't. But in 400 years, we built 8.5 meters telescopes, and that makes you wonder what's going to be in 1,000 years from now.
Considering that we've already got them in space.
Yeah. So what made you be an astronomer?
What made me an astronomer? Well, it's a combination of things, but since I was little, I was really impressed by the night sky. I had this uncle that was an amateur astronomer, engineer. He was not an uncle, he was an uncle of my mom, actually. So an old guy. A great uncle. And when he died, he wrote in his testament that he will give me the telescope. And so I got the telescope, and for some reason I always was living in cities, and I always preferred to do sports, so I never used the telescope. But maybe I felt bad about it, I don't know, but I also like to study physics, and I like to study everything, but physics I always found it quite interesting. And then years after years I found my way, and then I had this opportunity to work in the US when I was studying for a cosmic ray experiment. And that was not really astronomy, it was more like particle physics, but using the sky. And then I went to master degree in astrophysics and did a PhD and so on. So it was more like I was not meant to be an astronomer maybe, but after a few years at university, I found appealing this research way of life, the kind of work that you define yourself, and you wake up in the morning and you just look for ways to understand things.
And look at stars falling in the galactic center. What a beautiful image must have been.
But most astronomers don't actually observe that much. I mean, I was working as an astronomer before in Mexico, and I was observing basically once a year. The modern astronomy, you just ask for telescope time. You get a bit of telescope time when you're lucky or you wrote a good proposal, and then you wait for your data. And then if you have good data, you spend months to analyze it and eventually publish something interesting, and that's kind of like the cold side of astronomy. But so working at this facility now is actually a little bit closer to the dream of a child. I'm actually there. I'm there in the desert. I'm moving the telescope, even though we have it's complex. So we have different people actually moving the telescope and different people using the instruments. But at least it's closer to the ancient astronomer way of life that was doing everything from building his telescope to trying to observe to trying to describe what he was seeing and trying to basically understand. So this is more astronomy, and the new kind of astronomer, the astrophysicist that he never goes to the observatory or uses the astrophysicist that uses Hubble will never go there. He's just waiting for his data every 6 months. So it's different. I mean, what I like about it also is that we are not hurting anyone, let's say, apart from students and I mean, we're not selling crap, we're not selling weapons, we're looking at stars. Well, that's the nice way to see it.
You're looking back in time and you're creating our future as the human race. So I think you're doing a great job, Julien. It's been absolutely wondrous talking to you and hearing about exoplanets, black holes, the galactic center, and every man and his dog.
Yeah. Well, you're welcome. Thanks for doing this podcast with me, and hopefully it will come out great. Okay, bye. Nice to meet you.
And now, just to finish up, we've got to say thanks to all the people who have contributed to make this podcast possible. First off, a huge thanks to the New Zealand Science Media Centre for allowing us use of their recording equipment.
Thanks to the amazing composer Rian Sheehan
for the intro and outro music. Thanks to the Kiwi Space Foundation.
And thank you, World Space Week Association. And finally, a big thank you to our guest from today, Julien Girard, for explaining what it's like to watch matter falling into a black hole.